Good morning, Algebra 2. Today I'm going to be covering solving systems by elimination. So if you have your book, take it out because I'm going to jump right into the lesson practice and do it with you. So first let's review. There are three methods that I've covered. We skipped one. Three methods for solving systems. And I don't have the sections for the others, so I apologize for that. But there are three methods. The first we covered was graphing. The second method we covered was substitution. And today's is elimination. Now, graphing, honestly, is the least accurate, but it gives us a visual of what we're looking for. Okay, the most popular methods are substitution and elimination, and usually we pick whichever one makes the most sense to use. Now, there are three types of solutions. You can have one solution, which is when they cross or intersect, or when you have a solution for x and y. You can have no solution, and you can have infinitely many. Okay, so that's a review of what we've gone over so far. These are the best methods, these two. So let's go ahead and jump into our lesson practice. It's on page 174, and I'm going to teach you through the lesson practice. So part A on page 174, the equations were negative 2y equals negative 6x plus 62, and negative x equals negative 22 minus 2y. Now, this method is set up right here probably to use substitution, but since I'm teaching you elimination, I'm going to go over how to do that. So, step one, the first thing I'm going to do is rewrite so that they are in the form ax plus by equals c. I think the book calls that standard form, but it's when your letters are together on the left, your variables, and the constant is on the right. So that is the first thing I'm going to do, and maybe I'll just label that with step one. So that is what I'm going to do. So if I rewrite this equation, if I want x and y together, I'm going to move x. So I would have 6x minus 2y equals 62. Okay, so I added 6x. On the next equation, I have x already on the left, so I'm going to move 2y. So negative x plus 2y equals negative 22. Step two is to create a pair of opposite coefficients for one variable. Now, opposite coefficients mean that like positive 3y and negative 3y, or negative x and positive x, or negative 11y and positive 11y. Notice opposite means same number, different sign. So looking at this equation, I notice that negative 2y and positive 2y are already opposite. So I don't have to do anything for step two because they are already opposite. So step three is I'm simply going to add my equations and solve. So if I add these two equations together, 6x minus x is 5x. These cancel, or in other words, they eliminate. That's why it's the elimination method. So equals 62 minus 22, 62 minus 22 should give us 40. And then I'm going to solve. So divide by 5. And x equals 8. Now, last thing I'm going to do is substitute value into any equation to find other variable. Okay, so if maybe you're not a step person, maybe you are, but this is just guiding, or because you're not here, not hearing, maybe seeing me verbally, now you have the steps written for you. So I'm going to plug this into any equation. So I'm going to plug it into here. So negative parentheses x plus 2y equals negative 22. I'm substituting 8. The opposite of negative 8 would be to add 8. So 2y equals negative, what is that, 14, right? Yeah. Divide by 2. And I have y equals negative 7. So I would say that these are my solutions. So I'm going to write my answer. You can circle here. Or you could write it as a coordinate pair. It means that your lines intersect at 8, negative 7. And because I've been given a pair of points or a pair of coordinates, I would say that these are consistent. So I think the lesson practice asks us to label these, and independent, that is what you call a system that has one solution. So you can decide which one is your answer, but they do want us to label it. All right, so moving on, that problem obviously was a little bit longer because I was showing you all the steps. So it'll get faster and faster the more comfortable you are with it. So part B, negative x minus y equals negative 3. 3x equals 2y minus 11. So let's go over the steps I wrote up above. The first thing I'm going to do is rewrite so that they're both in standard form, which means x and y are together. In my top equation, x and y are on the same side, but in my bottom equation, they are not. So I'm going to subtract the 2y so that I get 3x minus 2y equals, this is a negative 11, so negative 11. Now I'm going to write him on top so you guys can see them together. So step 2 is I need to create a pair of opposite coefficients. And I do that by multiplying my equations. So I can either choose x and do 3x and a negative 3x, or I can choose y and get a positive 2y and a negative 2y. Doesn't matter which pair of variables you choose, you pick the one that you'd like to use. I'm going to do x. So I see that this x is already positive. So the opposite of a positive 3x would be a negative 3x. And this x is already negative, so I'm simply going to multiply this entire equation by 3. So I'm going to multiply entire equation by 3 so that I get opposite coefficients. So I have to multiply it by everything. If you leave off one thing, it's going to ruin your entire problem. So be checking your work, make sure you're distributing correctly. So 3 times negative x is negative 3x. 3 times negative y is negative 3y. 3 times negative 3 equals negative 9. Now, that was part of step 2. I did step 1 over here. Here was step 2. Step 3, I'm going to add equations and solve. So I'm adding these two equations. 3x minus 3x eliminates or cancels. Negative 2y and negative 3y is negative 5y. Negative 11 minus 9 is negative 20. I'm going to divide both sides by negative 5, and I get y equals 4. Now, I'm going to substitute y equals 4 into any equation and solve for x. So I'm going to plug it into this first one. So negative x minus, we just found 4. Now, careful here, if you guys wrote negative 4, again, it's going to ruin your other value. A negative divided by a negative is a positive. So equals negative 3. I would have to add 4 to both sides, so negative x equals 1 divided by negative 1, and I get x equals negative 1. So I'm going to leave it like that, and then I'm going to write that there is one solution, so this is also consistent and independent. Okay, next one. So for this one, I'm not going to write my steps because that is what takes kind of a while, and I've already written them twice. So part C. Oh, of course. 5x plus 7y equals negative 36. 2/3 x minus 8y equals 22. Now, step 1, done for me. Both of these equations are in standard form where I have x plus the y term equals the constant. Now, the thing I don't like is that I have a fraction, and I don't know if you remember how to get rid of fractions, but I'm going to multiply the whole thing by the LCD, which in this case would be 3. So I'm doing this to get rid of fractions. Okay? And when I say multiply, I mean everything, right? Equal sign means that if I multiply this by 3, I have to treat this side by multiplying it by 3. So I'm going to distribute everything by 3. 3 times 2/3, the 3's cancel, and I get 2x. 3 times negative 8y is negative 24y. 3 times 22 is 66. Now, I see these two equations, and I'm going to write them next to each other. So I'm going to bring down the 5x plus 7y equals negative 36. Now, I have two choices. I need to make either the x's opposite or the y's. It's 24 and 7. Those are big numbers. I'm not going to deal with those. 2x and 5x. So I'm going to eliminate x. I need positive 10x and negative 10x. Because 2 and 5 both go into 10. I can multiply. You can never add, you can't add something to each of these terms. You have to treat it fairly, which would mean to multiply. So I'm going to multiply the top one by 5. That would create the positive 10x. And I'm going to multiply the bottom one by negative 2. That would give me the negative 10x. So I'm going to distribute each. So 5 times 2x is 10x. 5 times negative 24, I got negative 120. Y equals 5 times 66, which is 330. So again, I distributed that all the way across. You have to do that. So if you pause, if you only multiplied it by this guy, wrong. If you only multiplied it by these two, wrong. You have to distribute it all the way across. So now let's distribute negative 2. I guarantee if you guys make mistakes and don't get the same answer, because you didn't distribute it correctly. So negative 10x minus 14y equals a positive 72, right? A negative times a negative is a positive. So I'm now going to combine these. The x's eliminate, 10x minus 10x. These are both negative, and I get a negative 134. Y equals 402. If I divide, make sure you're dividing by a negative. A positive divided by a negative is a negative 3. Don't forget your negatives. Then I'm going to substitute that back in. To any equation, I'm just going to choose the first because it doesn't have fractions. So 5x minus 21 equals negative 36. I'm going to add 21. That would give me negative 15. So x also equals a negative 3. So you can circle them separately, or you can write them together, your choice. All right, moving on. So part D. 1/2 x minus y equals 15. 1/4 x plus 1/3 y equals 0. Now you can pause and try this one because you need to multiply both equations by your common denominator, make for much easier problems. Okay, so the top equation only has one fraction. So I'm simply going to multiply everything by 2. That's the only denominator. The bottom equation has denominators of 4 and 3. And my least common denominator there is 12. So I'm going to go ahead and distribute 2 all the way across. And that gives me 2 over 2, or 2 times 1/2. 2 1/2s make a whole. So x minus 2y equals 30. Remember, you have to multiply the whole thing. Next one, 12 over 4 is 3. So 3x plus 12 over 1/3, or 12 over 3, is 4y equals 12 times 0, 0. All right, so here I'm going to choose y. So you can choose x. I choose y. So I need a negative 4y and a positive 4y. If I look at my two equations, I already have a positive 4y. So I need to make negative 2y a negative 4. It's already negative, so negative 2 times 2 gives me negative 4. If you chose x, then you should have multiplied the top by a negative 3, because negative 3x will be the opposite of positive 3x. So I'm going to distribute that, and I'm going to write the result here. So 2x minus 4y equals 60. I get 5x. These eliminate, equals 60. Divide by 5, and x equals 12. I'm then going to plug 12 in. I'm going to do this top equation. So x minus 2y equals 30. I'm plugging in 12. Subtract 12 and I get 18. So y equals negative 9. My apologies. All right, so again, these are consistent and independent. E. I have negative 7 equals y plus 3x, and 15x equals 50 minus 5y. All right, now these aren't set up very nicely for us, so I'm going to get it so that I have it in standard form. Remember, I need it to be in ax plus by equals c. I need it to be in that form. So I'm going to rewrite each of these. So I'm going to rearrange this so it's in order. So 3x plus y equals negative 7. This one, I've got 15x. I would have to add the 5y equals 50. Okay. Now, it doesn't matter which equation you choose, which variable. I'm going to multiply by negative 5, and I'm going to write the result here. So remember, distribute it all the way across. So negative 5 times 3x is negative 15x. Negative 5 times y It's negative 5y. Negative 5 times negative 7 is positive 35. So notice these both eliminate. This is 0 plus 0 equals 85. So does 0, notice none of my variables are left, and so I'm left with this statement. Is this true or false? This is false. So there is no solution. Okay, I'm going to do one last one, and that is part F. So our last problem for this section, 4x equals 10 plus 2y, and 5 equals 2x minus y. All right, so the bottom one is already in order. I'm simply going to rewrite him. So I'm going to move 2y, so 4x minus 2y equals 10. I just subtracted 2y. And then I'm going to rewrite the bottom so it lines up. And in order to make these opposite, I'd have to multiply this by a negative 2, because negative 2 times positive 2 is negative 4. I'm going to write the result here. Negative 4x plus 2y equals negative 10. Now when I add these two together, I get 0 plus 0 equals 0. Does 0 equal 0? That is true. Everything eliminated. So for this one, it would be infinitely many. Now this is different than getting y equals 0, x equals 0. That's okay. But here my letters completely eliminated. And that's it for that lesson.